Cycle. What is Otto Cycle? An Otto cycle is an idealized thermodynamic cycle that describes the functioning of a typical spark ignition piston engine. It is a thermodynamic cycle most commonly found in automobile engines. It developed by German engineer Nikolaus Otto in 1876. And now, let's see the four-stroke and the diagram itself. In the first stroke, which is the intake stroke, when the airs enter the cylinder and the piston getting downward, the volume increases. In the second stroke, when piston travel upward and the air will compress, since its compression, volume increases and pressure decreases. Before we proceed in third stroke, we need something to give power, and that the combustion comes in. Spark plug will produce combustion, also known as heat addition. At this point, the spark plug fires and sends the piston downward. By utilizing the heat energy from the combustion, pressure decreases and volume increases, and it's called the power stroke. After using air and fuel mixture, the waste need to evacuate, and it's called the heat rejected. When piston travel upward, the air and fuel mixture will release, and it's called exhaust stroke. Finally, that's how the four-stroke will do, and it's graph. In process 1 to 2, we have T2 over T1 equals P2 over P1 raised to the K minus 1 over K equals V2 over V1 raised to the K minus 1. We derive it to T2 equals T1 times P2 over P1 raised to the K minus 1 over K. And then we have the T2 equals T1 times RK raised to the K minus 1. Process 2 to 3, V3 is equals to V2. They are constant, so that we need to cancel it out. And then T3 over T2 equals T3 over P2. We need to derive them to P3 equals P2 times T3 over T2. In process 3 to 4, we will see that V4 is equals to V1, V3 is equals to V2. We can say that RK is equals to V4 over V3. We all know that T4 is less than to T3, so we have the T4 is equals to T3 over P3 over P4 raised to the K minus 1 over K. In heat addition, we have QA equals M air times CV air times T3 minus T2. While in heat rejected, we have QR equals M air times CV air times T4 minus T1. Network of the cycle, we have W net equals QA minus QR. efficiency of the cycle, we have 9 equals 1 minus 1 over r raised to the k minus 1 times 100. In mean effective pressure, we have the derived formula Pm equals W net over Vd equals W net over V1 minus V2. Let's apply the formula in the sample problem. An ideal Otto cycle with air as the working fluid has a compression ratio of 8. The pressure and temperature at the end of the heat addition process, the network output, the thermal efficiency, and the mean effective pressure for the cycle are to be determined. The graph will be like that, and given is Cp is equals to 1.005 kJ over kg times K, Cv is equals to 0.718 kJ over kg times K, K is equals to 1.4. In process 1 to 2, which is the isentropic compression, we have T2 is equals to T1 times V1 over V2 raised to the k minus 1, and substitute the value is equals to 300k times 8 raised to 0.4 is equals to 689 Kelvin. And then we need to derive the formula into P2 is equals to V1 T2 all over V2 T1 times P1. We need to substitute it into 8 times 689k all over 300k times 95 kPa, and the k is cancelled, and it was equals to 1745 kPa. We need to substitute the value according to the formula. We have 750 equals 0.718 minus k times T3 minus 689 times k. T3 is equals to 1734 k. Also, we need to derive the formula into P3 is equals to T3 over T2 times P2. It equals to 1734k times 689k times 1745 kPa, and it equals to 4392 kPa. Next is T4. We need to substitute the value to 1734k times 1 over 8 raised to 0.4, and it equals to 755k. The heat rejection, we need to substitute the value into 0.718 times 755 minus 300, and it equals to 327 kJ over kg. Next is W net is equals to heat addition minus heat rejection, and it equals to 750 minus 327 is equals to 423 kJ over kg. In letter C, we need to follow the formula and substitute into 423 over 750 is equals to 56.4%. Before we get the mean effective pressure, we need to get the V1, and V1 is equals to 0.906 meter cube per kilogram. And let's proceed in mean effective pressure. Let's substitute the value into 423 over 0.906 times 1 minus 1 over 8 is equals to 534 kPa. And that's all for Otto Cycle. Thank you for watching.